Hey, oh, yes, I remember this one.
There you go.
This is the one where I like walked off and then wanted all the answers.
Oh, that's nice one. Alrighty then. So, we're good.
Not what I did with my feet.
So it seems that with the calculations that we had last time, some of those were super wacky and confusing, and we'll go back over them. I don't know that we're going to go back over them today, but some of you found some really good online calculators or calculator apps to do those calculations with, and I promise you those are being done on apps in college chemistry classes. Nobody's doing them by hand anymore, those lucky dogs that they are. Trust me, we did, and it stuck. So let me put our notes up for today. Why do I not see it now? I thought I had it open. That down. So today we are doing concentration and molarity. So this topic's interesting in that, well, the molarity bit is helpful. I was telling the other group, theirs was talking about concentration and how you can describe concentration as the ratio of solute to solvent or the ratio of solute to total solution. So it can get confusing. So that's why molarity is nice, because it's always the same thing. All right, so solubility and the dissolving process. Good times. Solubility and polarity. Now you guys are getting to the point with your notes where you're going to start outlining the chapters, by the way. So look at your notes this week. And how were they set up?
Questions.
Yeah, there are questions. All right, now look at your next set of assignments for notes. Look like a lesson ahead.
Yeah.
Oh, what do we have? Here we have slotted notes like we had before, where you have to go through and find the word that's missing or whatever. Eventually, by the end of this quarter, there won't be notes in your binder. You'll be expected to do your notes. Still be homework, but there won't be notes. Yeah, and you're going to start taking notes on the chapters yourself, because it's really helpful to be able to know how to outline a chapter. It's also good to know how to take notes on a lecture, but I find if you've got an outline on your lesson before you get there, then if you leave enough space, when you get to your lecture, you can often write like off to the side or in the margins or below or wherever you've left room. And when your college professor is yammering on, you can take notes. I've kept some of them because they're so amazing, but I would get those spiral bound notebooks. I loved those for class. And some of them have little pockets in case you got a handout, but I would sit there in class and just write. And there are some classes, semester long classes, that I went through 3 of those, just solid notes. So a lot of you guys like to type for notes. Do anybody type to take notes during lectures? I don't like that because I feel like I'm paying too much attention to the typing and I'm not listening. Plus I make that hand to brain connection when I do writing. So everybody, do your own thing. So solubility and polarity. So what's solubility? Solubility is, you good?
Yeah, I just went too far.
Is the ability of a solid, liquid, or gaseous chemical substance, what do we call that? Solute, to dissolve in the solvent, which is usually a liquid, but not always a liquid. And the solubility of a substance fundamentally depends on the solvent used, as well as the temperature and pressure. And there's also a couple of other things like surface area too. So here's a graphic for you that gives you solution, suspension, and precipitate, which you guys know. But you also have supernatant, if that's the part of the solution that the precipitate crashes out of. And they will call it that, crashing out of, which is kind of fun. Okay, so why is it possible? We're going to go over your questions here. Why is it possible to overdose on vitamin A but not vitamin C? Your questions are going to be tucked in with your notes. Ethan.
Vitamin
A. Oh, sorry. Ethan put his hand up, Michael.
Yeah, Michael. So the body can excrete vitamin A through peeing and stuff, but because it's water soluble. But I'm in vitamin C.
Yeah.
But vitamin A you can't
Right.
get rid of through
It's
that.
fat soluble, so it absorbs in fat.
Right. So vitamin A collects in your body fat
Thanks, man.
because it's fat soluble. C is eliminated in your urine. You can take all the C you want. There are people these days taking 50,000 grams of vitamin C. My friend at the hospital is taking 50,000 grams of vitamin C every day. But she doesn't want to get sick, and I don't blame her. So for fun, I put up some examples of vitamin C and vitamin A. So you can get C and all these delicious yummies here. Ooh, grapefruits and lemons and tomatoes, and also chives and cilantro. And there's your vitamin A. Yes.
I was gonna ask, is overdose the correct term? Do you know that?
I mean, maybe,
Drinking
but
too much.
yeah, I don't know. Probably not the best term. But you often hear vitamin A with carrots. People often talk about carrots, and see, it's also retinol. Good for your eyes.
Well, oranges have a lot of vitamin C.
Yes, they do. All this stuff is all these good. I mean, look, grapefruits are on both lists. Yummy. I love grapefruits. Does anybody else like grapefruits? Nobody else in my family eats them but me.
Okay.
Freaking love grapefruits, man. It's also one of my favorite smells. Oh, I love grapefruit. Anyway, so like dissolves like. This is what the answer to that question about vitamin A and vitamin C. Like dissolves like. So what's that mean? So it has to do with polarity. Your polar substances dissolve polar substances. So conversely, that's going to mean your nonpolar substances are going to dissolve your nonpolar substances. So here are some examples here. You have your polar molecules and your ionic compounds that dissolve by your polar substances. And then you have your nonpolar substances that are dissolving nonpolar molecules and organic compounds. And there's a little, it's hard to see in this picture. There we go. I can see all the little things they put in there for your fun. Ooh, fun and graphics. Look, chlorine, lithium. That's exciting. Awesome. Fun thing. And then, so the next question on your list, when a substance can dissolve in another, it is said to be soluble. When it cannot, it's said to be insoluble. So for two liquids, what do we have? Oh, wait, that's not the question. I didn't label it correctly on here. Miscible. What's miscible mean?
Dissolvable.
Yeah, in each other, right? And then you have immiscible, which means
Not able to.
right. So give me an example of two immiscible liquids.
Water and oil.
Perfect. Straight up easy. Like that picture. And how about two miscible liquids?
Water and soap.
Ethanol and water.
Ethanol and water. There you go. Okay.
I wonder where you
Or-
got
I don't know.
that. Oh, man.
That probably just in my brain.
True.
So what was in your what was in that developing solution today? So I ordered chromatography developing solution, and the first company gave me this has been back ordered and we don't have it anymore. So then I ordered it from a different company who said, this has been back ordered and it might come in time. So I ended up just making my own. So it was water, acetic acid, and ethanol. That's what was in it, which worked very nicely as a solvent, as you saw, because it turned out pretty, I
So
think.
to be clear, it wouldn't have killed Drew if he managed.
The
to get
ethanol
it
might have.
out.
There's a lot of ethanol in there.
So it might have killed Drew.
It might have.
if he
Yeah,
actually
yeah.
found-
When you do histology, which is cell prep, they use ethanol for desiccation, so that's drying out. So basically, you'll prep a slide. So we did, for example, we did a couple of different things, but the mouse brain ones are probably the best example for this. So we get the little mouse brains and you put them in a dye or whatever, and you put them in a little paraffin block. Okay, so that's not hard, right? Stick them in a little paraffin block, and then there's this big machine. Best way I can describe it is it's kind of like one of those meat deli slicers, but it's way finer than, poor Abby. It's way finer than that. You crank this little wheel. I know. Wait till next year. But you crank the little wheel and it cuts like nanometers of thickness. I mean, we're talking itty bitty. So the blade is really fine. And basically it's so thin that the paraffin at that thinness, just the room temperature almost, it makes it more malleable. So as you cut one after another, they just come out like a ribbon, like they stick together. So they come out like a big ribbon, and then you can lay them on the slides. You can further stain them if you need to, and they just kind of melt right onto the slides. And then what you do is the desiccation with the ethanol. So you'll start with ethanol at like 25%, 50%, and you get to like 100% ethanol, and you put them in one little box for a while, then you take them out, put them in the next little box for a while, so they get completely dried out, which preserves them. I've actually got some that are 24 years old or something
Are
upstairs.
you
So
okay, Abby?
Abby's like,
You have mouse brains upstairs?
yeah, and crayfish nerve cord and all kinds of things.
No, I'm good.
Yeah, mouse brain. Well, I didn't take it out of the mouse. It was already, I got it as a,
That's Slightly better.
Does it look like when you took an
It
apple
is.
in the oven and dry it out? Does it look like that?
An apple? No. It came in a preserved liquid. So I mean, it was like whenever you get a sample to dissect, it came like that.
Okay.
And I don't get how she's scarred from the frog experience. You're the one that y'all made me cut the head off. Like, you couldn't do it, and I had to do it.
Listen, all I have to do is watch.
Fortunately,
I
They've
can still
come
remember
up-
how it felt.
Okay,
yeah.
that's enough, sir.
Yeah.
fortunately, they've come up with some really good graphic videos where you can go through and do a dissection virtually. Like it'll say, separate the membrane, and it does it on the screen and it's all graphic. It's not a real image. It's all a graphic image.
Oh.
So I was gonna say, if there are some of you that are particularly squeamish or you just don't want to do any dissections, those are options for next year. So, but I like getting my hands in it. So ethanol. Why is ethanol miscible in water? So this is it's doing it for you. Look at that. Whoa, check it out. Look at that. Ah.
Is the ethanol supposed to be the
I
green
found the brownie point
Yeah, the ethanolist. What'd you find?
can also form hydrogen bonds.
Oh, you're right. There you go.
Either,
Oh.
that's probably supposed to
Good
be
call.
formed.
Should be formed, yep. So it shows you right here where the bond takes place.
We had like two.
And so let's watch it from the beginning again. So watch, here's your water. They're just chilling. Woo, they're friends. Here comes the ethanol. Click.
Just give it
Look
time.
at that. Click.
And there was one right in the beginning of last week's
Oh,
lesson.
Lord have mercy. Yeah. Uh-huh. You are so good at
It
this.
was- I can't remember it, but I didn't manage to get a screenshot of it.
That's okay.
But if you go back, there's.
I believe you if you say you found two. Uh-huh.
Ethanol is just like high.
Yeah, there you go. I'm gonna take them.
I
Right.
think that puts us to 13.
It might. I'll have to look. All right. So solubilities of solid compounds. So this kind of looks like our crystals that we got in that volumetric flask that were really cool.
Mhm.
All right, so greater surface area speeds up the dissolving process. So here's your good example, is your sugar versus your sugar cubes. So solubility of both ionic and molecular substances generally increase with increased surface area and increased temperature. So here's your increased surface area. Imagine you have a lukewarm glass of water and you stick your sugar cube in versus you stick a spoonful of sugar in. Which one's going to dissolve faster?
Sugar.
Yeah, the one that's not, because you've increased the surface area. You've allowed the water to go all the way around all these little grains of sugar, all the way around the crystals. And it can do a better job of grabbing them and snatching them off. So yeah, there's your example for surface area. And now when it comes to dissolving ionic compounds, here's the thing. You guys know this from back when we talked about how they're soluble. And we did the first bit of, way back in the fall, we did ionic compounds, right? So what water actually does with ionic compounds is it breaks the ions, breaks the component into the ions, which is why they are conductive. Remember when we were running electricity through salt water versus just tap water versus just distilled water
And sugar water.
and sugar water. There you go. So it's called dissociation, and that's the separation of ions from the lattice into the individual dissolved ions. And then hydration actually is the name of the process of is the surrounding of the dissociated ions with the water molecules. So it's probably not hydration the way you think about it, but it kind of makes sense. You can almost put it right to that sports drink question. You can almost put it right there and go, okay, well, if I'm hydrated, yes, it means I have more water in my body, but it also means that all those ions floating around in there have a water with them, right? So here's the solubility rules chart. These are fun. You can find these all over. And this is not something anybody should need to fuss about memorizing, but it's a good thing to have or to know where to access, right? Because it's got great data here. Like it gives you, here's your ionic compound, right? This guy with this guy, or this guy with that guy, right? It's just like a grid. And it'll tell you whether it's soluble or insoluble. So, or slightly soluble. Handy dandy to have.
Michael, you have an Aussie with you.
Yeah, Osty's under the table. All right, so saturation. So we're going to be using these hot plates soon. And I asked the other group about this too. So this is, I just liked this picture. Somebody took great art photography in the science lab. So you see what's going on in the flask?
Tornado.
Yeah, there's like a water tornado in there, right? Do you know how that's happening?
It's spinning fast.
One of those little things pills in there.
Yeah, okay, so you've seen me do it.
No.
So our hot plates, they don't just get hot, they have a magnetic stirrer. So there's underneath in here, there's a magnet it's like a circular spinning magnet. And you get these, it looks like a pill, it's about this big, and you drop it in, and it has, positive and negative end, and if you slowly turn it, it'll catch. You don't want to ever like have the spinner on and then drop it, because you may catch it kind of midway and it causes either or just it sits there, it shakes like it's crazy.
Yeah.
But drop it in and turn it on, and it'll start to spin, and it'll stir your solution for you, which is super handy if you've got something that's going to be there a long time and you need it to heat up. And
Or
Lots of
if
fun.
you do something else wild.
yeah, and it's kind of mesmerizing to watch it too, because it goes makes this little noise as it goes around and around and around. So then we have the issue of degree of saturation. All right, so when we talk about saturation, we're talking about how much solute is in the solvent, right? So if you have an unsaturated solution, you've got less than the maximum amount of the solute that's capable of being dissolved, right? And you can keep dissolving more. If you keep putting more in, it'll keep dissolving. And this is all assuming at the same temperature, right? That's the assumption here. And then your saturated solution, that's when it can't dissolve anymore. So next week in lab, we're going to make a saturated sodium chloride solution. And we're going to do that by just continuing to add sodium chloride until we stir and stir and stir. And we're not heating, but until we stir and it doesn't add anymore. And we'll know that because the crystals will stay at the bottom. And we'll give it a few minutes and we'll wait and see if anything else dissolves. And then we're going to filter it. And once you filter it, you know you have the most saturated that solution can be at that temperature. Now, how did we get the sodium acetate to hold way more? We changed the temperature, right? Right, because that increases the solubility. Right. So then your supersaturated, which is what we had today in lab, the demo, contains more than the maximum amount that's capable of being dissolved at a given temperature. And this is, it says, even becomes unstable in crystals form. So when Lily dropped that one crystal in, that was enough to cause the crystals around it that are still in that solution to orient correctly, right? So it's almost like they all snapped in line, which is really kind of cool because you can actually see it, and you don't ever see that kind of thing. It's really neat.
Similar to how you temper chocolate, or you need to see the chocolate in order.
Yeah, because you don't want it to bloom. Is that what you mean?
No, because if you don't temper the chocolate, you get up to
Yeah.
a certain point, and when it melts, it doesn't melt back correctly.
Right. Yep.
It's dull. It doesn't snap well.
Yep. It doesn't shine. Yep.
It's
Uh-huh.
but if you bring it up and put it into normal chocolate shavings,
Yeah.
then
Mhm. Good. I assume you've done this. What have you made?
I've seen it. I think we did it for the frogs.
Oh, you make chocolate frogs?
Uh,
Oh yeah, I got me lots of them. I do them every
we
year.
did them.
All right, Potter Party, here
And
they
we
go.
even filled them with different things,
Very fun. Very fun.
but that was years ago.
So some of these solutions are so supersaturated and so unstable that they don't even need the little crystal. They just need a tap.
Mhm.
And that's what happened with one of mine today, right? Barely tapped it and it's like, ouch.
Think that if you put it on a table and pump the table, even
Yeah.
just a bit. it'll-
Yep, sometimes it will.
Trigger.
Sometimes it will. And if you keep, like the one I made today, if you get it back to the point where it's totally solution again, you can leave it somewhere where it's not going to be messed with, and you can leave it there as long as you cover it so nothing else falls in it. As long as you cover it, it'll last for years. And you can solidify them and reliquify them and solidify, freeze and liquid and freeze again and again. And one of the videos I saw online of a teacher doing it, he had that beaker in his classroom the whole year, like sitting up on a shelf or something. And the kids had seen it all year, but they didn't know what it was until he was like, oh, watch this. They were all, whoa, wait a minute, the thing's been there forever. I didn't know it did that, which is pretty cool. So solubility equilibrium. So these are dynamic equilibriums, which we're going to talk about a little bit the next couple lessons. So it's a type of dynamic equilibrium that exists when a chemical compound in the solid state is in chemical equilibrium with the solution of that compound. So what's that mean? So here's a good little graphic down here. You've got your salts put into the water, it begins dissolving, continues to dissolve. However, dissolved ions also precipitate. Because the salt dissolves faster than the ions precipitate, the net movement is towards dissolution. So it's still dissolving. And then it says, eventually the rate of dissolution will equal the rate of precipitation and the solution will be in equilibrium. But the ions will, and there, I didn't type this, you can't get me for the 1L, continue to dissolve and precipitate. So there's your formula for it. We're not using it too much. I don't know that we're actually using it at all, but now let's see, gases and liquids. All right, now temperature, let's think about this for a minute. Temperature and solubility. What's the proportionality? Direct, indirect for solids. Direct or indirect?
Direct.
Temperature and solubility.
Direct.
Yep. If you increase the temperature, you increase the solubility of most solids, right?
Mhm.
Okay,
We
perfect.
used that in that first one when we went virtual with the cold water,
Uh-huh.
and I think it was like potassium something or other.
I can't remember either. I made so many videos in the last 2 weeks that I was getting ahead of myself and making them. So, yep. Okay. And then, all right. So what do we say? We just said that. All right. Then how about, and surface area, is that, what's the proportionality there with solids?
Direct, I believe.
Okay, there you go. All right, now pressure and gas is Henry's law. So this says that at a constant temperature, the amount of a given gas that dissolves in a given type and volume of liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid. Here's the thing to get out of this. Directly proportional. Okay, if you have greater pressure, you have what as far as solubility of a gas?
Greater solubility.
So the converse example would be you open your soda bottle and what happens? You've just decreased the pressure. What's the first thing you see?
Bubbles.
Bubbles, because now they are less soluble because you just decreased the pressure. And Jason showed you his keg a couple weeks back. And we have that, I think you were gone, yeah. So he had just loaded new homemade cider into the keg. And we actually pressurize it with, there's a CO2 tank on the back, and that gives it fizz.
Yeah.
It's super pressurized right now. Like I had to tap, wait like 10 minutes, tap, because it's like so many bubbles right now. But that's because they're being forced under a lot of pressure and they'll dissolve in that liquid. So remember that pressure and gas solubility are directly proportional. Pressure on solids doesn't do much, right? For solubility. So here's one of your questions. A commercial fizz saver pumps helium under pressure into a soda bottle to keep the gas from escaping. Will this help keep the pumps helium gas into a bottle? Will this help keep the carbon dioxide in the soda bottle? What do we think?
Yes.
We thought so because we thought the helium would force the CO2 into the liquid.
Okay.
Yeah.
What do you think?
The fact that the introduction of noble gases increases pressure, therefore the CO2 stays
Okay.
in the solution because it
Okay.
pushes it further down.
Anybody else have a different answer?
As long as it was always pushing down, it never.
Yeah.
Okay, as long as it was always pushing down.
Yeah.
So
As long
here's
as
what
it-
the,
As long as it didn't push down and then release.
yeah, I think the purpose of the question for your book, the way they worded it is here it says a given type of gas and a given type of liquid. So what they're looking at, or the point of the question from their perspective, I guess when they wrote the book, was that no, because Henry's law states that it is the partial pressure of the same gas in a solution which keeps the gas in the solution. So increased pressure of only helium would have no effect on the solubility of CO2. But I was thinking the same thing y'all were thinking, that the general sort of atmospheric pressure within the bottle, if you pumped, are they saying they're going to pump more gas in it than it already holds? It's just going to put greater pressure in general on the entire system. So I think that answer makes sense despite what was in the book. Because I was like, what do you?
That's what it's saying.
I get where you're going with this,
That's
but
saying you're gonna fill a room with water and then fill in the next door room with oil and opening the door, suddenly all the water's gonna come out.
yeah,
Even though the
right.
water's-
No,
Oil's
that's absolutely.
It's just gonna all go out
Mhm.
through the oil.
Now they do, and here's why I also think it's silly, because they do make these little things. There's a picture of one,
Yeah.
and and they make them for wine too.
Yeah.
But all it's doing is pumping air,
Yeah.
which contains carbon dioxide, but it's not solely carbon dioxide. And they do work to some degree because they put it back under pressure. The wine ones do the opposite. They create a vacuum so that you don't lose the flavor. So I think your answer makes more sense than the book answer. I'm glad y'all answered that way. So physical properties of solutions. All right, physical properties. Electrical conductivity. So we know that what type of substance did we talk about that is definitely going to cause some conductivity when dissolved?
Ion.
Ionic, right?
Ionic
Very good.
compound.
All right. So here's a picture for you. Conductivity, the measure of the ease at which an electric charge or heat can pass through a material. So we got an ethanol, no conductivity. Some potassium chloride, high conductivity, because what kind of a compound is that?
Ionic.
That's ionic, right? And then acetic acid, it says low conductivity.
Acetic acid
So-
is vinegar.
An electrolyte. So what's an electrolyte? Yeah, it is. What's an electrolyte? It's a compound which produces what? You said it. Ions, right? Produces ions when dissolved in a solution such as water. When you drink Gatorade or Powerade, what are you tasting that is a familiar ionic substance? They're usually pretty salty. You taste the salt in them. Like it's not like drinking juice, right? They're salty. That's why. Those are the ions that you're trying to get. And then your non-electrolytes is a compound which does not produce ions when dissolved in water or a solution such as water. Duh. So hydronium. Hydronium can be formed when an acid is present in water or simply in pure water all by itself. Its chemical formula is H3O plus, and it can be formed by the combination of the H plus ion with the H2O molecule. The hydronium ion has a trigonal pyramidal geometry. See it? Doo-doo-doo. And is composed of 3 hydrogen and 1 oxygen. Because hydronium and hydroxide ions can move without actually moving, we'll talk about that in a second, can move without actually moving, and thus without having to plow their way through solutions by shoving aside water molecules as other ions, and as do other ions. Solutions which are acidic or alkaline have extraordinarily high electrical conductivities. What do they mean by move without moving?
This is like when they introduced imaginary numbers.
Imaginary numbers. Okay, so this is,
Imaginary
you
number?
have to think like charge. Think about charge. Now that you have charge in mind, what do you suppose they mean by move without moving?
Swapping around which molecule
Mm-hmm.
is
You're getting
turned to the ion.
Yeah, you're getting there. You're getting there. Yeah. So you've got your H2O here and your H3O here. And can this H just pop off and onto this one? I mean, that's the hope.
It could.
Basically, it's like you've moved that hydronium ion an entire step in your chain, but really you didn't. You just moved the H plus.
Yeah.
So that's what they mean by move without moving. So they do help with conductivity, which is the point. So why does tap water conduct electricity, but distilled water does not? Okay, what's distilled water?
It's water that's had stuff removed
It's
from it.
it's like the steam that comes off the boil.
Yeah, basically, yeah.
Completely.
So think about if you
Pure.
know what a still is, or if you live in the South, you might know what a still is. Or distilling is basically the process of you boil it, you get this stuff at the top, the water or whatever, comes back down, that's distilled. Therefore, it has nothing else in it but pure water, right? You distill things in a still. A still, like the kind they use to make distilled spirits, like moonshine or whatever, that's the same process. They will put the mash, whatever they're cooking, that's got the sugar in it, down in the bottom. The mash is like barley or wheat or whatever you're using, rye, whatever you've got. And goodness knows some of these places. And you boil that up and you get that vapors, the alcohol vapors will go up, right? And then they get to the top and they're actually collected and sent through a cooling system that condenses them back into liquid. And that's the alcohol that comes out the other end, which is why distilled spirits have way higher alcohol content than like wine or something like that. So that's how they do that. Cool it down and okay, later. So tap water contains what?
Mineral.
Dissolved ions and minerals. Yes, all kinds of stuff. Dissolved ions, minerals, things like that.
Yeah.
I know.
I think the comma was a period from this room.
Oh my gosh, you're hilarious. Okay. So
Nah.
colligative properties. I love this word, colligative properties. So these are the properties that describe, oop, look, I got it for you, did. That should be a
No.
TH. Describe the physical effect of a solute on a solvent. Colligative properties are those that depend upon the concentration of the solute, molecules or ions, but not upon the identity of the solute. So colligative properties include vapor pressure lowering, boiling point elevation, freezing point depression, osmotic pressure. So this little graphic just shows the 4 of them here and how they're all colligative properties, but they all link together. So examples, elevation of boiling point. So this explains how you can cook spaghetti faster in salt water, but you can cook it faster once it reaches a boil, but it takes longer to get to a boil because you've elevated the boiling point, but it's hotter than it would have been otherwise. So it will cook faster once it gets there. So if you salt the water, it's going to take longer to get to the boil because you've raised the boiling point, but it's now hotter. So your pasta will cook faster and taste better. You should always salt your water. Depression of freezing point. So this is why they put salt on the roads to keep ice from forming. So instead of 32 degrees, it'll be a little below that. And that will help keep the ice from forming on the roads, or at least keep it melting. The problem is you have to have the liquid there for it to actually work.
I actually just thought salt was on the road so the tires could grip to something.
So what they put here on our roads is it's a brine, and it's a mixture of salt and sand. And the sand is probably what you do see a lot, and that is there for grip. The sand is absolutely there for gripping, and it will make a terrible mess. But the salt is there to lower that freezing point, which will make it have to be colder in order for the ice to be there. But in order for that to happen, you have to have the solution. So it sort of depends upon, like cars kind of driving over it and mushing it down and grinding it all up together so that you start to get a little bit of the liquefied
There's always
water.
been some with water though over most snow.
Yeah.
Yeah.
Well, and the problem here in Georgia, as you probably know, because you've lived here long enough, and if you're driving, you certainly know, is we don't get snow on our roads, we get ice, right? And everybody that lives up north laughs, says, I think of these idiots. I absolutely love, there's that whole SNL skit with, who is it?
Oh, it's so funny.
Yeah, where he comes in and he's
Oh, yeah.
driving his Escalade because there's snow in Atlanta. What was it? Buford Calloway. That's his name. I mean, it's perfect, right? It's perfect. Yeah, Coca-Cola. Yeah, I'm drinking my ice cold Coca-Cola. Yeah, it's great. I'll have to show it to you. But anyway, they call the devil's cocaine or devil's dandruff, something, the snow, like it's terrible stuff because they don't get snow apparently. Yeah. Anyway, but what we get here is we get a layer of ice, and then that's under the snow, but it's usually a very thin layer of ice. But the problem is that as the cars ride over that ice, they and right over the snow that's on top, they compact it, and then that becomes more ice. And no matter what you do, and it's because we have that little, like what was it, 7? But when we had the snow again a couple years ago, I think there were 7 snowplows in Fulton County. I think that was what was reported. It's like the one where all those people got stuck on the highway and like babies were born on the connector and kids in school buses. Were you stuck somewhere?
Yeah, I was stuck in traffic a mile away from my home for
my
2
gosh.
hours.
Oh my goodness.
I was like 8 at the time. I was in elementary school home. Yeah, I couldn't.
It was
I couldn't
rough.
Walk home.
For those of us that lived through it, it was terrifying.
That was the one where I'm like, I'm glad now I'm in
What's
homeschool.
funny that
I don't
the
remember.
city of Atlanta has
I'm
2
trying
shows,
to
like 3 shows
remember.
out, the whole city.
We were just at home, yeah.
Yeah.
Make-
It was a while back, and it was this like in this time frame that we're in right now, this time of year when we get the random snow in February, but
I love
It
that.
snowed last night
a little bit.
For us.
well not
But
here.
we had the snow and the ice, and it was a combination of problems. A lot of it had to do with schools not releasing early enough.
Yeah.
And the big kicker was that, so like Forsyth released, Fulton released, Gwinnett, all the surrounding counties released. City of Atlanta didn't release until like 1:30 in the afternoon. It was already snowing.
Yeah.
And they released with no warning. Like every other county sent out emails and said, we're releasing the students in, 45 minutes. And everybody ran home. Ugh! It was already crazy because everybody was running home. Atlanta said, we're releasing now. And all these parents who worked in the city of Atlanta were like, and they come piling out all at the same time onto the roads. And everybody hit it at the same time. So the snow's coming down, And there's no
Really?
plowing, there's no nothing because everybody is already stuck in a traffic jam and that just caused absolute pandemonium.
Were there kids who like ended up having like spent a night on a bus or something?
Yeah, and there was a lady who had a whole, like she had the whole special needs bus and the bus driver was stuck on the road and some lady had to let the whole busload of special needs kids into her house. Like all the wheelchair bound kids and the kids with all of the equipment, they had to haul it all off the bus and bring it in because they were in the bus. They were gonna be in the bus for God knows how long. I mean, could have been there. Some people were on the road for overnight.
Yeah.
I knew somebody who was overnight. And Father Tripp, our priest,
Remember this.
left right over here, and tried to get back to his house in Cherokee County, and he got as far as Fulton, got near the hospital in Fulton.
You
And
just come back to
and
church?
he just got out. No, because he was like, there's nothing else I can do. So he couldn't come back, and he was stuck. So he went into the hospital. Of course, he'd been at church all day, so he's all collared and everything. And he goes in, and everybody's like, "Oh, because they're all sad." And he's like, "Sit down." Like, I can't even right now. Like, don't. Yeah.
Actually, I do remember this.
Do you remember it?
Where I was in Alpharetta and I was staying with my dad that night.
Oh yeah.
And my mom's like, "Don't go anywhere. Don't go out with her." And he's like, "No, we're going to Target. We're gonna go to Target and get some food and stuff."
Oh no.
I remember that.
Yeah, we had to have two of my teachers stay at my home.
Oh my gosh, are you serious?
Yeah.
Wow.
Stay at your house.
Yeah, we had two. It was my first and
Because he was a
second.
mile away, so he was the closest.
Yeah, my first and second grade teacher. They were
Jeez.
both friends with my mom. My mom was like, "Yeah, you can just stay with us," and then they ended up staying at my house.
So another collocated property is the lowering of vapor
Right.
pressure.
Oh,
So this explains the value of putting antifreeze into your radiator to keep your car from overheating. But if you think about this again, these all go together. It keeps your car from overheating, but it also is elevating your boiling point so it doesn't overheat. It doesn't turn into gas over here. It doesn't have to get it has to get really high before it boils. And then over here, of course, it's called antifreeze for a reason, right? Like you don't want the water in your radiator to freeze. That would be bad. And then osmotic pressure. So I love this one. And it says it explains why your little brother killed the family fish when he placed them in pure water while
Oh,
cleaning
yeah,
the tank.
exactly.
Yeah. Okay.
No,
So,
that was one
well,
of the temperature.
uh-oh, what did you find now?
Just looking.
Okay.
This you really
The
want brownies.
suspense is real.
I know.
You gotta know, like,
So-
Really want that.
Yeah, for real. So we'll talk a lot more about osmosis in biology next year, but it has a lot to do with water moving across from one system to another system to keep an equilibrium, to keep a balance. So if your fish is a fish that's used to living in water with a certain amount of ions in it, and then you throw him in pure water, it's gonna suck those ions out of his body
That was the problem.
into
Yeah, Drew put him in
no,
warm
Drew put him in warm water because he thought it was cold.
Yeah.
Yeah, you killed that fish.
And yeah, he went in shock.
Totally. Oh my God, it was awful. He was like, it's cold in the schoolroom, and he made a nice warm bath, and then he was so sad.
Yeah, so he didn't kill it with because of
Well, no,
Warm water.
that's temperature, but yeah, you
he
can kill
actually
them.
killed
It's
it with
not.
kindness, 'cause he was trying to be nice.
So one more thing I'll say. So you ever seen the trick with slugs and salt? Anybody ever done this one? Yeah. So people will do this. They'll kill slugs by putting salt on them or what. If you put salt on them, they just completely die. And the reason they die, Cole, it again has to do with this. It's actually a homeostasis when you get into biology, but it has to deal with osmosis. And yeah, there's pressure involved too, because basically now you have all this salt outside and it's a really high concentration and it wants to neutralize with the salt content inside the organism. So it's going to take water from wherever it can to find that balance. And that water is going to come sucking out of that little mollusk so fast. And that little thing is going to shrivel right up. And that's why it works. Yes.
We're doing biology next year, right?
Yep.
How are we doing
Math
that?
is in biology.
Nowhere near this much. You'll be very happy. That's why I didn't major in chemistry. I majored in biology. 'Cause I don't love the math either, man.
Yeah, you know, we both are not very good at math, correct? My favorite science is biology.
It's good.
You're good.
We
You're
did
good.
it. We did it 4 years ago, but we did sort of a version.
so
Next year's
long,
version will be
Holy
so
cow.
much better.
Yeah,
It's going to be awesome.
I love
Come on,
biology.
chemistry was 5 years ago.
Mhm.
We met each other 5 years ago.
Actually, no, you guys met in the first chemistry. So yeah, that was
Yeah,
that was
we
5. You're
met
right.
in-
You're right. You're right. Five. Mhm.
the striper one.
So why does spreading? So here's the
Oh, yeah,
question: Why does
I
spreading
read the
salt
one
on an
later.
icy? Cool. Why does spreading salt on an icy sidewalk cause the ice to
Yeah, I
melt?
figured.
Because
Huh?
All
You
right?
want to answer? Since you're talking. Why does spreading salt on an icy sidewalk cause the ice to melt?
Because it lowers the freezing.
There you go.
temperature.
Lowers the freezing temperature. We just went over that, so we should all have that. lowers the freezing, the vapor pressure too, and the freezing point, causing it to melt at a lower temperature. So here's this nice little diagram too, where you can see the effect of this particular component here. So you've lowered your freezing pressure and your vapor pressure. You can see where they all
Yeah.
kind of lower together, right? And the boiling point's raised, chunk, chunk.
Yeah.
And see this right here is the worst thing, man. Oh God. Don't ever let it get on your car. You see this dude, if you see this dude in the winter, stay back. It's like the mosquito man, but
You
worse.
can't avoid it.
Like, no, it's
Mosquito
stay
man.
back. Y'all don't have the mosquito man, and I don't understand it.
What
Because
is it?
so when I was a kid, we had the mosquito man. Do you have the mosquito man? That comes to your yard?
Yeah.
No. When I was a kid, we
No,
had.
no, not pest control.
This is
Oh.
not them. So that okay, child of the 80s and early 90s. All right. So the mosquito man was a truck that the city government sent to your neighborhood, a little pickup truck, and it went and it had a yellow light that flashed on top, and the dude sprayed pesticide into the air as he drove through the neighborhood because he's trying to kill all the mosquitoes because they suck, right? So,
Literally.
but what would you do? What would you do?
Did you
I
get
didn't.
blamed the pesticide?
I didn't because I wasn't completely dumb. But a lot of kids I knew would just run behind the truck or ride their bikes behind it because you'd get misted. It felt nice, you know?
Oh
And it's amazing any of your parents even are alive. Like we should all be, we should all be
That's the
different.
reason
Out of
we don't have
curiosity.
any
Right,
anymore.
there you go.
my. Out of curiosity, how many likes do these kids have now?
I don't know. You think they'd have multiple legs. It's funny, but yeah, the mosquito man was great. I don't understand why you don't have him because man killed all the bugs. And he was great. You'd hear him coming. I would run in. See, some kids would run in, some kids would follow. But you'd hear him coming, and everybody would be together on the corner, like we were in the 80s with our bikes, you know, around the corner, mosquito man! And half of us would go in, and the other half would go to him. You know, it's like it's one of those things. Who's coming? All right, so surfactants. All right, so surfactants here, we're getting into detergents and surfactants and this sort of thing. So a surfactant is a substance tends to reduce the surface tension of a liquid in which it is dissolved, concentrated at the interface of the two phases. So what's that mean? So yes, that looks like something else, but it's a surfactant. This is what they look like structurally. I knew everyone would
Do you
do
have
that.
to say that?
If I didn't say it, these
Somebody
three.
would've said it.
If I didn't say it, these three would have been like over here for the next 30 minutes, and I would get going anywhere. So, are you swimming? Are you the little surfactant moving with your? Okay. All right. So surfactants.
I heard my ears.
So here's this right here. This is those micelles. We talked about micellar water that they sell in the store. This is a micelle here. So
Don't
it's
drink it.
a surfactant. A detergent is a surfactant or a mixture of surfactants with cleansing properties. Okay. And this is why surfactants work. They have a hydrophilic or water-loving head and a hydrophobic or water-hating tail. And they will take that water-hating end, attach itself to the oil here, and take the water-loving end and attach it to the water and get the oil right out of your dishes, which is why dish detergent works so well. And then soap is different in that it's a cleansing and emulsifying agent, and it's usually by action of alkali or fatty acids and consisting essentially of sodium or potassium salt. So your soap is not a detergent. It's a mixture of other stuff, tends to have some fats, oils, that kind of business in it. And then you also have an emulsion. So an emulsion is a fine dispersion of minute droplets of one liquid in another, which is not soluble or miscible. So probably the most familiar emulsion for you guys might be mayonnaise. Anybody ever made mayonnaise?
I know how it's made.
How do you make it?
So you take eggs and oil,
Mm-hmm.
and you basically just get it like something called an emulsion blender, which is like
Does
different,
work, yeah.
and you basically just the power stir basically
Yeah,
to
it
the
is.
oil and eggs, and you get it to the point where they're like you literally can't separate them again,
Mm-hmm.
and then
Yeah.
that's what an emulsion.
That's exactly right. Yeah. So,
So
It's just a really good mixer.
if you were to take,
It
like,
basically
let's
is.
say,
It's just a
wait, she's asking.
like, does mayonnaise count as like protein since it's made of eggs?
It has protein in it. Not a whole ton, but yeah. Yeah.
Yeah,
So
they
my
eat all the
my
body.
great aunt has a mayonnaise recipe that I actually have, and she made it from scratch, and she made it with a wire whip, like not an immersion blender or anything. She would just, but it was so good because when I was little and we would visit Canada where she lived in the house she grew up in my great grandmother's house, but she would make us these tiny little sandwiches that she would cut the crust off, and she'd cut them into little little triangles, these little cold cut sandwiches she'd make for my cousin and I. And she put her homemade mayonnaise on them and she'd stack them on a silver platter and then give us bowls of blueberries and cream and brown sugar and sit us at the main table like we were special. It was pretty awesome. But yeah, and I have her recipe. Maybe if there's a day we have extra time, we can try taking turns whipping. But
Okay.
everything this year is so hard because we try not to get anybody sick. So, oh, and one other thing about surfactants that's important you should know. So you actually produce a surfactant, probably more than one, but the one that's probably most important is surfactant in your lungs. So this is one of the things they check for with babies that are going to be born premature is they check for certain, they can draw amniotic fluid and they can check for certain levels of certain compounds that could be in it that give them an idea of whether or not the baby is producing surfactant. And you have to have surfactant because it reduces surface tension, but it's also slippery. Okay, so your lungs are like sponges that take up air, right? But they're wet, mucousy membrane type material, right? But they have air in them.
Yeah.
And if you deflate them and there's no surfactant, they go and they're stuck. And inflating them is really hard to do. You ever had a balloon that you've blown up so many times and you got so much spit inside of it and I can't blow it up anymore? You ever had that experience? Okay, that's what happens to baby lungs that don't have enough surfactant. So they can actually do some things to help promote the production if they know a baby's going to be delivered early. But if you've ever seen a baby that they don't know is going to be delivered early, and have you ever seen like TV shows or whatever where they do like it's a medical miracle, when they put babies on ventilators. Have you seen ventilators in adults in movies? They're like a big breath and they relax and a big breath. The baby ones go like this. And they don't ever allow their lungs to fully deflate. It's like this constant. So their little chests are moving. And it's because if they let that breath go all the way out, those lungs could just stick together and they're not going to come. That's it. So you have to let them constantly stay inflated, but there's a quick exchange of gas. It's really strange looking if you've never seen it. Like, it's like, whoa, that doesn't look right. That looks like torture. So here's a question for you. A water softener removes calcium and magnesium ions from water. Why does a softening agent improve the cleaning ability of soap? Who had that answer? I think that's one of your questions.
Yeah.
What'd you get? What'd you get?
I assumed it was because the softened water had no minerals for the soap to also work on getting.
There you go.
So if the soap is focused on outer materials.
Yeah, so the ions removed from the water would have formed compounds.
Yeah.
With that soap. So this is what happens if you have hard water. If you have hard water in your home and there's all those nice ions in your soap, they're going to form with these ions in your water and form compounds. And this is what forms that. You ever seen just straight up calcium in your shower? It happens all the time. I mean, even if your water is not really hard, you can still get it. Yeah.
Is the sorry, Alpha. Is the homework turning or you keep reminding me?
I think it was a keep in mind that we were going to read over it. Okay.
Oh.
So
Oops.
that's okay. That's all right. Whatever. I think it was. I mean, I can look, but
I saw other people have turned it in, so I turned it in.
so here's the homework. I'm pretty sure it was.
It was the paragraph.
Yeah, but I'm pretty sure it was to
Paragraph.
share. Let me
Paragraph.
double check it.
Paragraph.
So here's your question. It's this one about electrolytes and sports drinks. So let me
Oh,
double check
let me
it,
go get
but I'm
mine.
pretty sure it said
Go get
to
mine,
keep it.
Go
Actually,
get
just
you,
grab the
man,
whole
too.
stack, honey, if there's any others. Yeah, it says keep it in the binder.
You want
So
Yeah, thanks.
Thank you, Aaron boy.
First, it should say the date was wrong on that. I caught it. So sports drinks such as Gatorade or Powerade are marketed to athletes to replenish electrolytes lost by the body during exercise. Research why the human body needs electrolytes, what types of electrolytes are used by the human body, which of these electrolytes are lost in the greatest amount through exercise, what types of electrolytes are in these drinks, and whether or not these drinks can be beneficial or necessary for athletes to remain healthy. It says write a short paragraph or create a diagram, illustration, or poster to share what you learned. Okay, so
I put in
Let's
mine
shoot.
so
What'd
much
you get?
short.
okay, tell me what you got.
Basically wrote like
Go for it. We might not all have the same answer, so I'm curious.
Mine said electrolytes are used by the body to regulate nerve and muscle function and hydrate the body. They also can balance blood pressure and blood acidity. Electrolytes help
Oh, I love it when I do that. I'm like, I wrote that. I don't know what it says. That's the best.
Oh, also, and
That's the best. I love it.
I kept saying, like,
No, I
for
love
some
it.
reason I can
I do that all the time. That's great.
body are sodium, potassium, calcium, magnesium, chloride, bicarbonate, and phosphate. Exercise can cause the greatest loss to the
Yeah.
body of sodium and potassium. Gatorade contains sodium and potassium. Powerade has sodium, potassium, calcium, and magnesium. These drinks are not necessary, but they are helpful during long periods of heavy exercise. For most everyday exercise, we can drink water.
Excellent. All right. Who else wants to go? You want to go? What'd you get?
I had basically the same thing as Jack.
Oh, yeah,
Both-
same.
both of
We
them.
got,
You
what,
want me to read some?
anything different?
Not really. It's the
It's
same
pretty
idea.
straightforward.
Electrolytes are essential minerals that provide many vital purposes to the human body. Some of these minerals include chloride, calcium, sodium, and potassium. These four minerals are specifically lost to the action of sweating. Without these minerals, the body faces a number of health risks, including muscle spasms, weakness, and blood pressure changes.
Ah,
While sport drinks are a great way to consume electrolytes, they are not the only way an athlete may take in different.
very good.
Yeah.
Excellent. So blood pressure, that's an interesting one. What mineral do a lot of, well, what compound, I guess, do a lot of people with blood pressure, high blood pressure avoid?
Sodium.
Yeah,
Salt.
avoid sodium and stuff. What?
So,
Dude, quit. Why are they avoiding the salt? Do we know why?
What the heck happened to you, Aussie?
That's not Ozzy, that's Otto.
What?
So totally different dog. Okay.
Never seen that before.
Yeah, that was good, Mom. They're like, hey. Yeah, I know. Old brown. Yeah. What happened to you,
Feels like he's a different dog.
Otto? That's funny. So the reason people with high blood pressure avoid sodium and salt in general is because we were talking before about homeostasis and osmotic pressure and all that. So if you have more salt in your body, in order to balance that out, your body's going to need more water to reach its nice balance. And when you get all that extra water, it's going to go in your cardiovascular system because that's where the ions are currently circulating, which means you're going to get more volume in the same system, which is going to make the pressure in the system go up. Right, good. Who has anybody have anything different that wasn't already said? Even just a tidbit? Nothing different.
They
That'd
assist
be
in
tight to
maintain fluid balance, neural activity, and muscle contraction.
Okay,
They're the
good.
main purposes of electrolytes.
Yeah.
Yeah.
Hmm. So what was it that Powerade has what that Gatorade doesn't? It has magnesium, calcium.
He did that.
What did you say it had?
It has calcium and magnesium.
Calcium and magnesium that are not in Gatorade. So that's good to know.
I think-
Okay.
I wrote down that sodium, potassium, and chloride are in both Gatorade and Powerade.
I don't like chloride.
No,
Either.
I would think
that was the other one. Yeah.
there would be some degree. Maybe not.
But that wasn't listed by Jack.
Okay. Yeah. No, that didn't. Anybody draw it or do a poster? Everybody just wrote it. Okay, that's interesting. So yeah, so if you had to pick one or the other, I'd probably pick the Powerade knowing this, right? That's really interesting.
Gatorade is the
It tastes
best.
better most of the time.
Lemon lime Gatorade.
Yellow.
What's your favorite? What do you like?
Blue.
Well, what?
What
What were you gonna say?
Hold
on.
Wait, Shannon had something.
I was gonna say, how are you supposed to do an illustration? Like draw a bottle? What do you?
I don't know. People get creative. I would have written it, but not everybody would. So I mean, you could maybe do the labels of both and compare, or whatever it is that you chose to do.
My favorite is the white Gatorade.
Oh, white Gatorade. Is it Frost or there's
Yeah,
blue in it?
Like cherry
Glacier
frost.
or whatever.
Oh yeah.
But it's the only one I can have, so that's why I like it.
Lemon.
Ah,
Lemon
okay.
lime is the best.
Do you guys have ones that you like?
Lemon lime is definitely the best.
I'm allergic.
Then
to
right
the color.
second.
But no one's like
Lemon
No one
lime
ever has
Blue.
like lemon
Blue
lime.
Gatorade
No,
is
but
the
lemon
best.
lime.
blue Gatorade
I'm
Look at-
allergic.
blue-
or blue Powerade?
Okay, look, no.
you
Wait a minute,
just
wait a minute,
touch
what do we
it
have?
and,
What?
Like
No.
something to shred.
Wait, Cole has a,
No, I'm just getting between those two drinks. I think blue Powerade's better, but as far as Gatorade goes, blue
Yeah.
Gatorade's the best.
You're
but there's
wrong.
2 blue Powerades because we've had this issue with Drew.
It's Mount Berry Blast.
Mountain Berry Blast is not the same as Very Berry or whatever, because that one tastes like Jello and he won't drink it, but he'll drink a Mountain Berry
Oh
Blast.
no.
Mount Berry Blast is great.
Yeah.
Yeah, that's the
lemonade
best
powder.
Powerade.
Have you got a favorite one?
Yeah, lemon lime.
The lemon lime
Lemon
too?
lime Gatorade.
Do you have a favorite one?
No clue.
I don't
Probably
really
not.
like it.
Yeah, no?
This is staying me off of it.
No.
Probably Bruce has-
No.
And can we all just agree that red
I drink any of them. I'm not picky.
the
Like,
fruit
Not
punch
picky,
Gatorade?
but
I'll go throw back to the old days and do
No.
the lemon lime or the
I'd
red
probably
one,
go-
whatever it is, or the
Yeah.
orange. I do like the orange.
Orange
Jason
is
likes the
good.
orange.
Okay.
We have a whole
Maybe.
powdered
I don't know.
thing of the orange in
I
there.
drink
Orange
more.
is good.
Okay, so
Three flavors.
let's real quick look so you know what's coming up.
No orange.
Yeah, it's always,
Yeah,
huh?
No orange is good.
You're wrong. Okay.
Come on, open up.
Now,
What are you doing?
now I know I'm
Vitamin
talking
water
wrong.
zero is good too. Do you have that?
Ozzy.
Vitamin water zero.
Vitamin water zero.
I have a friend who's a professional opera singer and she swears by smart water. That's her thing. She goes for the smart water every time she gets a chance because she drinks that
I had it
before
once. I
performances or
had it.
whatever. Yeah, I know, you
It's
know,
like it's water.
it's water.
It's water and I think we call bottle.
So since we are, what happened there? I did not click on the right thing. Hello. All right, I'm just gonna show you guys, look at the next couple weeks real quick here.
Can we do an experiment on like what Dasani is and what it's made of sort of thing? Have you seen
Oh,
any of those?
Don't we have
yeah,
a
it's
couple
online. There are
different-
some that people have compared to bottled water. and It's like,
Yeah,
What?
Dasani and like normal bottled water.
yeah. Yeah, it's interesting. You can check pH on them all and all that
Yeah.
kind of business. Actually, we did that last year. What did we run pHs on? It was bottled waters,
We use
wasn't it?
pHs in like the second chemistry.
Yeah, we did waters.
Did we
Wasn't
did,
it like we
yeah.
like
It was
tap
when we
water?
were
also
at
remember
home,
that?
right?
No.
We'd already
Remember
gone
the
home.
First or second chemistry?
No.
We did pH, like the
Nope.
tabs and the.
Nope.
I remember it
Nope.
very
That
well.
was all you meant.
Stop. What are you talking about?
So, alrighty. So you guys, we are doing,
I think you fibbing, dog.
you don't
What?
have a
You just
test
said-
this week?
Fibbing? What does that
What is
mean?
wrong with
Shouldn't
you?
you have a
Who
test?
says fibbing is 1897?
I guess not. I
Make
don't think
fibbing.
so. Okay. All right, so we are wrapping up chapter 13, and for whatever reason, I didn't put a test in here, so I'll actually combine them, I think, 13, 14, maybe.
Okay.
Um,
Well, now we can have-
I'll let you know, because I didn't put it in there. And then, because
Okay.
that's weird, I don't know why I
Yeah,
did,
there's just no test.
that's a screw up.
Yeah.
That's what happens when you do
Is
this,
it
this whole
bright
part of the
white?
summer. So, yes, moving on, next week, we're doing,
Yes.
so, was it what? I didn't.
No.
No.
You agreed
Oh,
to
no,
something.
that, no, I didn't hear what you said. I was answering yes, like, say it again.
You agreed to something.
So there's the chapter 14 test is next week. So so I'll make that chapter 13 and 14. I'll combine them together. Since it's the same topic still, we're still talking about solutions and stuff to a bit. We're moving on to equilibrium. But like I said, when you look at your notes, you'll see I basically have that format here, right? I put the format in place for you pretty much. There are I did find a couple formatting issues in here that like, I didn't do them, but whatever it is,
The document.
yeah,
They burn
it's
it?
doing that. No, because they're not. I didn't do it.
Yeah, sometimes it just.
It just doesn't want to the auto formatting thing, and you're like undo, and then you think it's undone, and it hasn't undone. So then we have after next week we have a week off, right, for winter break. So we have next week off.
Oh.
Come back on the 23rd, and
Spring.
well, not quite yet. It's come back on the 23rd, and we'll be at we'll be at lesson 24. And,
All right. I know it's coming at the very fast.
Then here we're getting into you doing a little bit more, your notes are getting a little bit less on my side, a little bit more on your side.
Yeah.
And
Yeah.
then by the time you get yourself here to lesson, that's 24, here's 25. 25 is gonna be even more so,
Yeah.
very little from me. All right, it's just showing you what you should be hitting on. Hit on this, hit on that, hit on this. And then
26 is the same.
26 is even less. It's a little, I think it's a little less even.
Yeah.
And then after this, you're pretty much on your own for outlining this last quarter. There shouldn't be any outlining really that I'm handing to you. You should pretty much know how to do it. And as you look, pay attention to, like, for example, nobody has their book right in front of them, but I have mine over here.
Mine's right next to me.
Oh, is it? Well, I'll show you what I mean. When you're looking for example, in 23, which is next week. So if you look after 14, wait, give me. I want to make sure everybody knows what they're doing here.
Pull it up for a reason now.
I got mine out 'cause it's right here, but you can look over there all you want. All right, so if you look at it, you'll see, for example, it'll say 1, that Roman numeral 1, and that's going to be your section 1. It's going to align exactly. So see, it says reversible reactions equilibrium. Then you have a red heading. That's going to be your letter, capital letter A, complete reactions, reversible reactions. And then your Arabic number 1 would be the blue section, like a subsection, right? And then whatever you put in there will be things like the vocabulary words or anything else you need to hit on between those Arabic numbers before you go back to another red heading. So it should line up pretty well. If you see something off in the formatting, that would be why. No, because this stupid formatting doesn't like to play. Like that should be a C, yeah. So anyway, that should be easy. You guys should be able to get through that pretty easily. And then your homework for next week is just a couple of questions, right? Okay, has anybody thought much about their,
Do we have to turn that one in?
that one is A, look. It says turn in, yep.
Okay. Just not keeping back there. Got it.
No, that was a turn in. So does anybody have any thoughts yet about your end of year project?
I
Dude,
went
what
to
are we-
helium.
What are we doing? Like, I need
Elementary
instructions
superhero.
now.
Yeah.
So
want
who
Leo.
was working with Ivy? One of you was working with Ivy. Oh, Sydney.
Oh.
Sydney wanted to work with Ivy, and now Ivy's gone, so I guess she's on her own. So let's look at it real quick for a minute. Let's just take a second and look, because I want to make sure that everybody is, aware of what they're doing. It's at the very front. Yep.
Of the syllabus?
It should be, I think it is after the syllabus.
No.
No.
To tell you our elements now.
If you want to lock your element in and
Neon.
make sure nobody
I
else
want neon.
steals
I want
it.
neon. I want neon.
I
What?
think,
You want
oh yeah,
that?
bismuth is good. Okay.
Bismuth.
Beryllium was taken because that was Ivy and Sydney. And then, so bismuth, neon. Okay, everybody hears it, right? I don't need to write it down. Y'all hear it. Uh-huh.
Sodium.
Sodium. Okay.
Helium.
Gold.
Gold. Okay. Excellent.
Neon.
I'm not
So
thinking.
here's the assignment, and this is funny. I'm bummed that Abby left. I'm sorry that Ivy. I looked right at you. Ivy left because this is right up Ivy's alley. But it's create a superhero or a villain,
Oh.
right? So it's really it should be really
I
fun.
think
So
sodium's better as a villain.
you'll have to
I'm ready to do villains.
so there's a layout, and it looks like this. So this is basically what you have to answer and the information you have to get, and then you're going to present it. But the information that you'll be looking for is it a superhero or a villain?
Oh.
And then you have to come up with a name and like an emblem, like a logo.
Oh, did we get
And
that
then-
paper?
It's in your binder. Should be in, what page is it? It's page
In
9.
page 6 of the pre-
9
preface.
in the preface, I think. Oh, it
Six
starts
in
on
the
6.
preface.
I'm on 9 right now. Yeah. You're right. It starts on 6. The project starts on 6.
So we just have to, is this just our final project right here?
Mhm.
Turn it in?
Yeah, well, you have to do what it says.
That's
So
why it was like
like,
the whole thing.
it says here, you're gonna need an 18 by 24 foam board and
Oh.
hold it horizontally, glue or tape your single page origin story on the left, and then your character illustration. So it'll be a front and back. You'll have origin story, illustration, fact sheet, works cited. And
My
so
goal
like,
is-
some people are not great at drawing and they don't want to do a character illustration because they're terrible at drawing. So go online, literally, I'm not kidding, go online or look in magazines, cut out the pictures and glue it all together and make a hodgepodge. I don't care, it
Like,
just,
well, your guy was the-
like, in all seriousness, it can be,
Never mind.
take a picture of a Barbie doll and put clothes on, I don't care. It can be anything. It's just to make you really think is the whole point, and think outside the box. And the reason I do these year-end projects is because I firmly believe in learning long-term project management, because a lot of adult life is long-term project management. You can wait to the week before to do this, but because I give it to you in August, means you have all this time, right, Alex? All year, because I give it to you in August, so you have all year to work, which means you could do it anytime and be done. I'm
Well,
not going to
maybe
tell you
next week.
anything last minute.
Maybe, yeah.
Let's do it over winter break.
What? Winter break?
Yeah, it's
Spring break?
in 2 weeks. You just said winter break. Use your ears, man.
Oh.
You said winter break? What?
I bet you could find a way to make that. You can make that into something though. Like for real, you could print that out and then cut it like it was like different pieces of clothing.
This won't be the vibe.
Yeah, Michael, your guys'
Yeah,
grocery store is
Absolutely, I do that all the time. Like go onto, like, go-
It's like a combination of words, so I could do like.
right.
It's like a-
Like if you go on to, for example, if you go on to, hang on,
The
let me
Miami
close all these
football
million
game
things.
at the background.
These guys are already like coming up with stuff. So if you go into Pinterest is a great place.
Yeah.
Okay, so yeah, that could tell. So if you go into Pinterest, for example, and you go in here and say, you're like, I just want to see some color swatches. What are my colors that I want to use for my hero?
COOLORS, and it'll make a color palette.
Yeah. See, here's ideas. Oh, here's colors of things that go together. And maybe my superhero is kind of chill like this, or maybe or you could say, I want to do something bright. And you'll have bright colors, or maybe you definitely want your superhero to be a female. Then you can say, all right, what's appealing? What might she wear if I want girly,
What?
quote unquote, colors? Or maybe you want it to be a dude, you can just put in dude. And here's what your dude pulls up, it's dude colors. Like maybe it's gonna strap dude.
Black and blue.
Or
Sure.
or you could just go old school and go, superhero. Okay, what do superheroes wear? Well, boom, they wear these colors, right? I mean,
Superman.
Or-
in Minecraft.
say you've done, like Michael has done neon. Oh,
Yeah.
boom, here are some color palettes that are
Oh.
neon. Or maybe you
Yeah,
picked
neon light.
lithium. Well, let's just see. Is there a lithium?
What?
Wouldn't be surprised.
It's just the Energizer Bunny.
Gives you ideas, right? Wow, 90s kid. Yeah, I love those.
You
Like,
can
those are
just-
great.
Yes, I
With the, just some little,
the whole.
just some little.
Or you could just do, say you picked
The
lithium.
burgundy
Just
superhero.
search lithium. What's there? Maybe there's colors. Oh, look.
Colors.
You never know, man. Maybe this is your superhero's head. You know, you could, maybe your lithium did. It helps with depression. It helps with depression, for real. See, all kinds of stuff that you can do. Sodium.
Completely crazy.
You're probably gonna find a million like high blood pressure things searching on sodium, but you might be inspired and go, oh, I like these colors. Or
Sodium's my thing. He just makes people get high blood pressure. That's the only thing he can do.
Villains.
High blood pressure just makes things silly.
oh, here's some superheroes. Maybe you want them to look like this or that, or maybe your superhero lives in the water. So you could do superhero of
I'm
the
sorry,
water.
Reef
Live in the
blue.
water.
Reef blue.
Reef blue.
Beef blue.
Well, here's some aquatics.
Look at
Sea foam.
I mean,
sounds like a-
fun, right?
Not sea foam.
Yeah, very reef
Green.
blue.
Just
Oh gosh, sorry. I thought yeah.
Beef rule.
Reef blue. Ooh, that's
That's pretty.
pretty. Ooh,
That's disappointing.
that's not what you wanted, huh?
No,
What did you want?
nothing.
Cyan.
Nothing.
Turquoise. Aqua.
That's official Mustang color. So.
Oh my gosh.
Blue.
Well, then you just have to just put in Mustang and it'll come up. Like maybe this is your boom, yeah.
Yeah, that's what I was looking for.
Oh yeah, it's
Okay,
this one,
right
isn't it?
here.
Yeah,
Yeah, that one.
that's a nice color. I agree. But see, those are fox bodies, old school. Cole loves the fox bodies. Gotta agree, they're cool.
I don't-
Hey, he'll be driving you because he'll have a license a year ahead of you, so don't fuss at whatever car he gets. So you won't have one. There we go. Of course, he won't have one either. He'll be driving ours probably, but hey, what do you know? So anyway, start thinking about it for sure. Start making some notes, start looking at some stuff. I mean, I know that I get inspired for creative designs by looking at other people's things. When I have to do cakes for people and all they say is it's a such and such party and they don't give me any, direction, I have to go start looking myself. And I come up with ideas on my own by combining things that other
We
people,
need to have a baking day where like
that'll work.
we bake our own cakes and you make like a professional looking one and try to see.
That's
No,
not
that'd be
bad.
interesting.
Wow.
Like I'm doing one next weekend, I'll show you.
It can be close.
So
I
I'm,
would just send it back and eat it.
This is a GoTen. Wow.
I don't like sauce.
so I'm doing one next weekend. They didn't give me colors. They didn't give me anything. All they said is wild one. We like the wild one idea. Well, their last name is Wilder. I said, so it should be Wilder one because that's more fun. But I decided what colors. I decided what design. It just, you look at stuff And-
They decided.
This is a smash cake. But you know, because the baby will, smash that thing.
Fuzzy.
Well, It's frozen. But yeah, so you just look, start looking and see what you find. Come up with some stuff and it'll be cool. All right, I'm gonna kill the share. You guys have about 15 minutes. If you didn't finish lab, you can probably wrap it up now. If you need to get something else to eat or
You want me
whatever.
to go put these back on the
Sit there,
stack?
get your lunch.